Hello friends, welcome to Macnotech YouTube channel. Friends, in the previous video we had seen a classification of follower, classification of chem and terminology of chem. And in this video we are going to see the motion of follower. So this is about the follower motion. So first is uniform velocity, second is simple harmonic motion, or we can say SHM. Third one is uniform acceleration and retardation, and fourth one is cycloidal motion. So this four motion is the follower motion. Okay, so let's start one by one. First one is uniform velocity. So here we have to see the displacement velocity and acceleration diagram for uniform velocity. So as shown in diagram, this is a displacement diagram. Okay, so here this is a displacement of follower, right? When this follower moves upward and downward, so whatever the motion of this follower in upward and downward, this is the displacement. So total height of the follower motion is this. Okay, now here you can see the knife edge follower. Okay, so you can assume here, from here followers start to move upward, and from here followers start to move downward, and from here follower having no motion. Okay, so there are, this period is called the dwell period. In a dwell period follower have no motion. Okay, so here it is in the straight line. Then this period is called the raise period. Okay, so in this period follower moves upward. Okay, and here this period is called the return period. So on that period follower moves downward. Okay, so here this is a displacement diagram in which this is also considered as a dwell period, and this is also a dwell period. Okay, so total there are 360-degree rotation of cam. We have to draw the dwell, rise and return of the follower. Okay, so based on that, here diagram is given. This is a displacement diagram, and this is a theta 0 angle, at particular angle at which the follower having a rise period, and this is the angle particular at which follower has a return period, and at particular angle when the follower has a dwell period. It is already given in the example when we are going to solve the example. So just now you remember, this is a dwell, this is a uniform velocity. Okay, this is a uniform velocity, we can say. Okay, then this is a dwell, and again this is a come to downward with the uniform velocity. So basically this is a uniform velocity diagram, displacement diagram of the follower. Now after that we have seen the displacement diagram. Then after, what is the velocity of follower at particular point? So here during this period it is uniform velocity. So during this period velocity considered as a 0, and from here followers start to rise with the uniform velocity. So at that time the uniform velocity will be the at that time the velocity will be s upon theta o into omega, and omega is the angular velocity of cam, right? So here during the uniform velocity it is a constant. So here s upon theta 0 into omega will be the constant during the raise period, and during the return period it is again same but downward side and minus sign, with the minus sign and downward. So s upon theta r, that is represent the return angle. Okay, so theta r is the return angle. Okay, so basically, and dwell period again it is on the 0 line. So this is a velocity diagram, and as this is a uniform velocity, the acceleration considered as a infinite. Okay, from here to here there is no time for the acceleration, but it is considered as a infinite. Okay, so this is a displacement, velocity and acceleration diagram for uniform velocity motion, right? So this is the first motion. Second is simple harmonic motion. So second is simple harmonic motion. So what is the difference between uniform velocity? You can see here, this is a uniform velocity diagram, displacement diagram, and this is a displacement diagram for simple harmonic motion. Okay, so basically what happened in this, instead of the straight line here, this is a uniform velocity. Okay, so how to draw this uniform velocity diagram? So first we have to draw a half circle as the displacement. Okay, here this is a displacement, okay, say 40 mm, 50 mm, whatever. So we have to draw the half circle, and then we have to divide this circle into 6 equal parts. Okay, so 180 divided by 6, that means 30 degree for each part. Okay, so 30, 30, 30. So, okay, so 30 degree each part, and we have to draw the line, straight line. Okay, so I will show you whenever we will do the example. I will show you how to draw this particular diagram. Okay, but you can see here, from here we can see the horizontal line. Okay, 3, 4. Okay, from everywhere we have to draw the horizontal line, and then we have to divide theta O into 6 equal parts. Okay, 6 equal parts, and again theta R, it is also divided into 6 equal parts here. So because why we divided 6 equal parts? Because here we have total 6 number of parts of this half circle. So one part will have 1 point, right? So here 1, this is 2, this is 3, 4, 5 and 6. So by this way we can get the path of follower motion. Okay, so this is called the simple harmonic motion. This path is called the simple harmonic motion. Okay, same here, like E, here we have a point H, then I, then J, then K, and then L, and last at M. Okay, so this is a race period, this is a dwell period, and this is a return period, and remaining angle is the dwell period. So the theta 0, theta D, theta R will be given in the example. Okay, so this is a cam angle, and this is a displacement. Okay, displacement of the follower, whatever the motion of the follower, up and down motion, right? So this is basically simple harmonic motion. Now what is the displacement, velocity and acceleration diagram for the simple harmonic motion? So as we have seen the simple harmonic motion, so this is a displacement diagram which we have seen here. Okay, this is a simple harmonic motion displacement diagram, so which is the same here, and written in middle it is s by 2, total s by 2, and you can see here in the velocity diagram, velocity of simple harmonic motion, in the middle the velocity is high, and at the end velocity is 0. Okay, so in the middle of race period velocity will be the high, and it is pi upon theta O s by 2 omega. Okay, so this is a main basic thing. Okay, and here also it is in opposite side, minus pi upon theta R s by 2 into omega, and during the dwell period velocity is considered as a 0. Now what is the difference between velocity and acceleration of simple harmonic motion? So here at the beginning acceleration is maximum, you can see here acceleration is maximum here. At the midpoint of race time, at the midpoint of race time acceleration is 0, and at the end of race period acceleration is again maximum. So what is the equation for the acceleration? That is pi square upon theta O square into s by 2 into omega square, and here opposite side it is minus sign with the opposite side, so minus pi square upon theta O square s by 2 omega square. Okay, now here as it is start from the lower side, so here it is a minus and again 0 at the center, acceleration is 0 at the return stroke center, and here acceleration is maximum at the end of return stroke, okay, and then after, if it is a dwell period, then again 0. So here this equation you should remember, this velocity equation, acceleration equation, and displacement, that is s by 2. So this equation you have to remember, and this is a second simple harmonic motion. Now let us see third one, that is uniform acceleration and retardation. Okay, so this is the displacement diagram for uniform acceleration and retardation. So now you know theta O, that is the raise period, this is a dwell period, it means no motion of the follower, this is a return period, follower return on this period, and again this is a dwell period. Okay, now in uniform acceleration and retardation we have to divide these 6 equal parts, and also from the middle we have to divide this also into 6 equal parts. Then we have to join, okay, so then we have to join this first part, second part at the, and third part. Okay, again third part, sorry guys, and third part from here it is also connect with the F, then fourth part, then fifth, and then 6. So by this way we can get the first point. When you join this part to here, you will get the first point. If you join the second part B to O, then you will get the second point. Third point will be the here in the center. Fourth point you will get here when you join, okay, and fifth part over here, and sixth part itself F. Okay, so by this way we can get the motion, we can say uniform acceleration and retardation. And from here it is the same thing, again divide into 6 equal parts. From the center take a vertical line, divide this vertical line into 6 equal parts, okay, and then first part you should join here and you will get the point here, second join here, you will get the second point here, third point at the middle, so, and here fourth one you will get the here, then H you join here, then you will get the here. Okay, so by this way you can draw a uniform acceleration and retardation displacement diagram. Now what is the velocity and acceleration diagram for the acceleration and retardation motion, right? So this is a displacement diagram that we have seen just before. Okay, this is a displacement diagram and this is a motion of the follower. Okay, and this is a displacement diagram shown here, same thing. Okay, and in between this is displacement of s by 2, which is described as theta O by 2. And one thing you notice here, the velocity is maximum at the center and 0 at the end during the raise period. Same way during the return period it is 0 at the end and maximum at the center. And the equation that you have to remember, that is 2 upon theta O s into omega. Okay, here same equation but in a minus. Okay, now acceleration, you can see here during the half period acceleration is maximum, then from the center of raise period the acceleration is same but it's in a downward position, means the negative side. So here the equation for the acceleration and retardation acceleration diagram, that is 4s omega square upon theta O square. Okay, and same here for the negative with the negative sign. Okay, so this is about the displacement, velocity and acceleration diagram of acceleration and retardation motion, uniform acceleration and retardation motion, right? Now last one is cycloidal motion. Okay, so how to draw a cycloidal motion? So theta O, that is the raise period, theta R, that is the return period. Now we have to divide this into 6 equal parts, and first of all we have to draw the circle, okay, then divide it into 4 equal parts, then again here from the 45 degree you should divide it into like this, okay. So 45 degree total you have to divide it into 8 equal parts, okay. Now this is a first and this is a second, this is third and this is fourth, right. Now you have to draw joint fourth and fifth, same way third and sixth and second and 1. You have to draw a horizontal line like this, okay, here already and like this, okay. Now from this point, let me show it again, from this point center you have to draw a line from like this O to F. From here first point you have to draw a parallel line, okay, and from here also you have to draw a parallel line, okay. So this 3 line is parallel to each other, okay, this 3 line is parallel to each other and it is start from the point here, here and here, right. So from this 3 point we have to draw a line which is parallel to OF. And then how to get the point? You can see here from this line we get the point from the first A, then from the second we have to join here, third it is at the center, then fourth part is from the top line, fifth part is it is also from the top line because 4 and 5 here, 1 and 2 is here, so we have to join 1 and 2 in the bottom line, then third is in the center line and 4 5 is in the last third one line, okay. So by this way we can get the path of cycloidal motion, okay. Hope you understand. If you have any query you can ask me, you can message me, okay, downward side. So this is a cycloidal motion of the follower. Now during the dual period it is constant, and same thing. Now what you have to do, you have to divide this into again 6 equal part. It means 6 and 12, 7 8 9 10 11 12, and draw the straight line and you have to just join this line. So you will get the H, you have to draw straight line and then again horizontal line, you will get this point, then again straight line, this is a horizontal line, you will get this point, straight, horizontal, you will get K, then L, same thing, okay. So by this way you can get the points, right. So this is the last one, cycloidal motion of the follower displacement diagram, and here this is a velocity and acceleration diagram for the cycloidal motion. So you can see here at the middle the velocity is maximum, okay, 2s upon theta O into omega. At the end of race period it is 0. Same way at the end of return it is 0 and maximum, but downward it is maximum, okay, velocity is maximum. Same way here during the acceleration, it means center acceleration is 0. It means here where the maximum velocity, acceleration is 0, okay, and acceleration is maximum at the middle of half, particular if we say half portion, and in the quarter, okay. So at the middle of half it is a maximum acceleration here, and it is 2 pi s omega square upon theta O square. And similarly here same equation but in a negative sign. So this is for the race period, okay, this is for the return period, and this is the center, and this is in between the center, means half portion of the center part, right. So by this way you can know the displacement, velocity and acceleration. Now here you can see screenshot of this picture, and this is a equation that we have seen for the simple uniform velocity, simple harmonic motion, uniform acceleration and retardation, and cycloidal motion, velocity, acceleration. Okay, these are the equation that we have seen. Okay, so friends, if you like this video, then press the like button, share this video to your friends, and you can comment whatever you like, and subscribe my channel for more videos. Thank you. Jai Hind, Jai Bharat.